If you're anything like me, you don't always want or need a powered kayak, but God almighty, when you see them, you salivate. And the thought of like throwing some contraption on the back, like a big 12-volt battery and a trolling motor, just sounds like a huge pain in the butt, and it's not a one-size-fits-all type situation, as well as a lot of the offerings out there by like Torqeedo and Bixby and stuff like that. They're okay, but they don't quite have the range, or they don't have the speed, or a combination of the two. And they're not well suited for all kayaks that are on the market. Well, that's where this video comes in. I have 4 different kinds of kayaks, and I'm going to build 4 different motor systems for the kayaks. We're going to do a long range system, we're going to do a second long range less powerful system, and we're going to do a really, really high speed long range system, and then we're just going to play around with a couple cheaper versions. And the amount of money I'm spending to do all these kayaks and all the batteries, it's going to be less than one commercially available kayak setup. So you guys are going to be able to get into an electric kayak with a decent range for under $200. And if you want to push that range and you want to push that power, maybe $500, maybe a little bit more, and a little bit of elbow grease. So it's a multi-part series, and I'm going to walk you guys through the steps, the tools, the techniques, and all the tips that you need to do this. This is going to be kind of a one-stop shop for powered kayaks, and it's going to be a bit of a series. So we'll probably have 6 or 7 videos. There's definitely going to be one system here that's going to work for you, or all of them, and maybe you'll just turn into a crazy kayak fiend and go out and buy 4 kayaks and put motors on all of them. So anyway, let's get to work. You're going to want to start with a decent soldering station, and that's because you're going to do quite a bit of soldering. A lot of these connections, you want really solid connections, so no butt connectors or anything like that. So what I have here is a Yotech 336 Power, and this was one of the ones that Banggood sent over. I can tell you it feels pretty light, feels pretty cheap, runs 60 watts I believe. I haven't tested this thing as far as like putting a thermocouple to it or anything like that, but I can tell you it's hot enough to fuse 6-gauge or 8-gauge wire, So this right here is some really good 8-gauge, and it was able to make that connection, no problem. If you want to spend more money, you can, but these actually have a pretty decent track record of staying alive. They're also under, I think it's Heidel, I can't remember. Anyway, pretty good little setup. Link in the description for that one. I really wasn't expecting much out of it, and I've been using it for a year and a half now, and I haven't had any problems. I've done a ton of jobs. The tip is just dirty. I've needed to clean it, which brings me to this little kit here. I just grabbed this off of Amazon because it was cheap, and right now funds are a little tight, right? So I got to go with the cheap stuff on some things, which brings me to this. I got this off of Amazon. I'll put a link in the description. It's essentially for cleaning your tip, but it came with just a bunch of extras, right? So all of this and the little side cut pliers, which I'll pull out of the package and show you here in a second. I think it was like $7 or $8, so couldn't beat that. Came with flux, came with some what is it? Rosin core, 0.06 millimeter, and that should do fine. And we'll test it and see if it's good. This obviously is advanced quality, high intensity joint, good immersion, and it has a neutral pH. You know, don't skimp on your wire, guys. Get some high quality large gauge wire. For all of this, I would say all of your leads running from a speed controller, it's not going to hurt you if you just grab 8-gauge. You know, just get some good wire. This right here is going to be the key to this project. It's a big motor. It's a 56 114. Now what that means is it's 56 millimeters wide and it's 114 millimeters long. And I'm just going to put it in my hand and show you guys how big this is. It is a monster. She is tough, man. It is a 360 kV. Now, what that means is this is going to be a torquey motor as opposed to a high-speed motor. And don't let that fool you. This thing's capable of, I think, 13,000 watts. It's insane. And also like 15,000 RPMs. So you can get it up there if you get your voltage high enough. So there's kind of a balance between voltage and amperage with these kind of things. And we're going to get into that in the build. So we'll talk more about that. But you want the lowest kV number you can find for torque, because we're going to be running a larger prop than I think anyone has ever run on one of these. So you're going to be making a lot of battery connections and jumper leads and stuff when you're adding packs together. I would highly suggest you just pick up some XT60s and use all those for your low voltage connectors. you'll be using these to like tie your batteries together and stuff like that. But when you come out to your final lead, you don't want, you know, these are capable of 60 amps. That's the XT60. You want something a little beefier. So then what you do is you step up to the 150s. Now these guys will carry 150 amps, and you can see the size right there. It's got some size to it. Speaking of which, you're going to want to be able to test everything. If you're pushing a lot of power, this guy right here should be okay. Now, I don't know if it's actually capable of handling 200 amps, but you put your load on this side, so that would be our motor, right? Or our speed controller, actually. So this would connect to our speed controller here, and then this would connect to the battery pack on this side. And this will give us all the information we need to know about the battery and what the system is doing. And we can actually unscrew this guy and then waterproof this entire thing, or we can set it up in a waterproof container if we like, and I will get into the techniques and tips used to do just that, because you do not want any of your electronics to mix with water. Now, having said that, what are we going to do about this motor? I mean, it's got holes all over it. It's not sealed in any way, and if water gets on this, boy, that would just be a disaster. That's not the case. This is three-phase. It's a DC brushless motor, so there's only one moving part, and there are no brushes. This can actually run underwater. Now, you don't want to run this under salt water, so you need to seal this guy up, put it into an aluminum tube, and then worry about a seal. My problem with sealing it is you have a very small surface to seal from, because you're missing, I mean, the shaft is ground all the way down to here. The shaft is ground all the way down to here, and that's a bit of a problem. So even getting a seal on this would be, I think, would be difficult. But once again, there are ways to negate any saltwater damage from this, or some saltwater damage, and we'll go through those as well. But the thing is I'm just going to run this guy open. Because it's going to be pulling things this direction, we will go ahead and seal off the back, but just this aluminum cased motor being in water is going to help actually more than it hurts by keeping this guy cool under high load. The biggest problem you're going to run into is finding a propeller, and I sourced the propeller, and I'll show you that now. It would be really nice if we could just pick up one of these propellers and make it work on this guy. Now the problem is, obviously, we have a 12mm hole and a 10mm shaft, so we need some kind of a coupler. We definitely don't want to be drilling a hole through this shaft because we're going to weaken it. This thing's got a lot of power, guys, and putting a hole in there could potentially weaken that shaft, so this whole design is off. So what I'm going to do is try to get one of these props and design it to work with one of these motors, but that is not my end goal. I'm using a different propeller. I've already ordered it, and it's going to be really cool. But a budget DIY thing would be to be able to couple this to just about anything. So I'm going to work on that as I move forward and see what happens. Now, another thing, you're going to be dealing with a lot of different batteries, so you're going to want to be able to parallel charge them. Like, one of my battery sets is going to be like 12 batteries, right? And unfortunately, I ordered XT30s. I didn't realize that. I need XT60 connectors for my batteries. This allows you to balance charge multiple sets of batteries. So I can do 1, 2, 3, 4, 5, 6 batteries on each one of these. So that'll allow me to charge 12 batteries. Now, when it comes to our batteries, we're going to be doing quite a few different things, right? I want to build multiple packs. So we're going to do some 18650 packs. I've gone through and tested all these. They're all good, and they all hold voltage, even this one. So these are salvage packs that I had out of tool batteries that were around here, and they're all pretty well balanced to each other. These are going to be great. They're going to give you a lot of power. I probably need double this, but that's not a problem. I can go to batteryhookup.com, and they can actually just provide me with some extra tool batteries. I think they're $6, and you get like half these batteries, like 20 batteries. It's pretty crazy. And then they have new batteries as well if you want to go that route, but I'd rather break mine down and save a ton of money, because this is going to be your best bang for the buck, and we can show you guys how to build this battery pack as well. Now, second up, this was, we're looking at $50 worth of batteries here. What that nets us is this is 7.4 volts and 10,000 milliamp hours, right? Put them together, you either have 14 volts and 10,000 milliamp hours, or you have 7 volts and 10,000 milliamp hours. So you can go for more current draw, and these are 50C, I think. Yeah, 50C, which means they can dump. So these guys can put out a ton of amps, like 200 amps per individual battery. So we're talking like 400 amps for that one, 400 amps for that one. This would run This motor, not a problem. It just wouldn't run it for very long at high speed. So maybe 10 minutes, somewhere in there. And that's not what we're going for. We're going for hours. We want hours of runtime, right? So it sounds expensive. You're like, well, getting hours of runtime out of that. Well, we're not going for hours at full speed. We're going for hours at a comfortable 2-3 mile an hour pace with a full speed run up to... Honestly, I'm going for too scary in a kayak. I want it to scare me so bad that I don't ever want to do it again, except for the one time we tested. So the motor and propeller combination that I'm working on should net us about 3 to 4 times more power than the biggest, baddest boy on the market out there right now in kayak propulsion. And it shouldn't even be a contest. We're doing things different than how they do it, and we're going for a higher RPM setup with a smaller, more efficient prop. I can't say more efficient. Their system's very efficient, and they're able to sell it to you because it's efficient and keep the battery small, but we're going to go for a bigger battery, allowing us for more power and more range. When it comes to charging, I picked up the Ultimate Duo 400 watt, and once again, Banggood sent this out and wanted me to test it for this video, and I've had it for a long time. This has been a long planned video, and I've just been doing research, guys, and trying to figure out the best way to do all these builds. So I've had the opportunity to go over this thing. You can see how dirty the manual is and really test it out and see what it's all about. So this is going to allow me to charge multiple banks of batteries. It has 2 sides here, 400 watts. We got 1 and 2. This is a good, robust charger, and so far it's lasted over a year. Really like it. So I'm going to build a pack like this, and then we're going to run these guys and test them just how they are, maybe in the small kayak with a smaller motor. And then I'm going to run some really, really big batteries. I got 8,000 milliamp hour, 7.4 volt batteries, so 2S, and I'm going to combine those. I have 12 of those on the way, but that whole pack's only like $250. So I'm going to test those batteries, see if they're a good quality, a high enough quality battery to use in this project, and that should give us a ton of power. And then once again, I'm going to go to batteryhookup.com, get me some more of these guys, and also they have these flat packs. I'll put a picture up of them right now. 8,000 milliamp hour LiPo packs, and I'm going to build a pack out of those. I'll make it probably I'll make 2 12S batteries, and we're going to go big on that one, so that'll be a really cool battery build. So kayak number 1 is a Jackson Cuda. I absolutely love this guy, but it is a beast. It's a very heavy kayak, works great on the lake, but it definitely, you know, this is not like a touring kayak. You're not going to want to go on very many long trips unless you have moving water, because it is tough to move, especially when you have it packed down. I'll put a link in the description to the 40-mile river trip Amy and I went down last year, and this is the kayak that I used. This is a fantastic kayak. I do fishing. I mean, it just works out so well. And as you can tell, I have tons and tons of storage room in this kayak, and it's darn good looking. The other thing is that it's already set up for everything we need. We have a place for our motor plate that I'm going to fabricate. We also have, I'm going to add in steering, but we're going to use a servo to control the steering. And I don't want a bunch of wires and cables everywhere. I don't want to see anything at all. So everything is going to be controlled. The motor will be down here, obviously, in the water, and then it's going to be controlled by these 2 cables here, but these are going to have hard lines in them, and there's going to be a 5th scale RC servo tucked back up in here at the bottom, and that will rotate, and I'll have steering control up front in my seat. So Amy's kayak is a Hobie with a Mirage drive, and she does really well in this. Kayaks are dirty, guys. I got to get them all cleaned up. We had a crazy rainstorm, and the spot they were in got covered, so don't mind the dirt. But anyway, she uses a Hobie, and it's a Mirage Revolution 11, so it's an 11-foot kayak, and this thing does great. It's cool because it already has the steering built into it, and that's fantastic. Now we're going to do the motor 2 separate ways. I'm going to do a cartridge, so I'm going to buy a cartridge, and you can just pop a cartridge in. It'll have a motor on it. It can be sitting by your feet. She can pull her Mirage drive out or put her Mirage drive in. But I think it would be cool, and I was talking to her about it. I'm like, well, you know, that's a good idea to have it, you know, just run on that in the front, but it would be better, and you could get more range if you were also using the Mirage drive, and we took another one of the fins. This is one of the cool things about this kayak. You pull this arm right here, like this, and it flips it down, right? So all we have to do is mount her motor up on the side like that. And I might be using a ducted motor, I'm not really sure. But that's going to be how we set that kayak up. This is my Perception Pescador 12 foot. And this has been a great kayak for me. This was my first real major kayak that I bought. And guys, I wore the bottom out of it. I need to fix my glue joint there. This is something I don't take on long trips anymore. You know, get too far from shore because I'm a little worried that I might not make it back. But that's where I wear life preservers. But anyway, tons of room. I think this kayak was $500. I really like this kayak. The bottom is burnt out in it, but guys, that's because it was used. I mean, I heavily used this kayak, and it's like 8 years old, I think. And still, I mean, to this day, I'd go out, put a little glue on the bottom, go out and throw this thing in the lake and have a great time. So this one here, we're going to try a different kind of motor, different kind of setup. And I'm not really sure yet which way I want to go. I have a couple different ideas. But as you can see, the most important thing to notice on these is that all the mounts are different, right? Mounting things to these kayaks is kind of the important part of this video, like showing you how to put the system together and then how you can mount them to where they stay on there and they're not a huge pain in your butt. The last, of course, is the venerable Pelican Pursuit kayak. This was Amy's first kayak. It's a 10-footer, and okay, I'll tell you what I'm doing with that one. I'm probably going to add a solar canopy to this one, right? So we're going to run it where it'll have a smaller battery pack and a less watt battery, have a top speed of like 2 or 3 miles an hour, and then run off of a 100 or 200 watt solar panel as well. Shouldn't be an issue for that kayak. It's got the perfect bottom for it. But we may do that with this as well. Or I'm thinking I may pull the battery pack out of that one, and since that's going to have the most power, pull the battery pack out of the Cuda and the motor as well, throw it in this thing and see how ridiculous it is. I don't know how fast it's going to go yet, but with my calculations so far, it's going to go... There's no question it's going to beat all the competition out there in kayak motors. It's not going to be... It's going to be a little scary when you do it. And then if you threw it in something like this that weighs like nothing... ooh, Lord. So anyway, yeah, making all the mounts and everything to make it secure to this thin plastic. That'll be important as well. But, so we'll do another motor setup on this and then make it to where I can just attach the other stuff and use it kind of as a test mule. And then something really fun like a beater kayak when people come over to play. And just to show you guys what you can do with yours. So that is 1, 2, 3, 4 kayak motor builds coming up on the channel. The Jackson Cuda, obviously, is first. This thing is a big girl. Really nice kayak, though. Tons of storage in there. I still have my chairs in there from last year. And, my God, you have just... I mean, you could put your battery up in here. It's all my fishing gear. It is a mess right now. I'm so sorry. I got to get it cleaned. Love this kayak. The seat is extremely comfortable. It's really big. And then all your space for batteries and everything in here. And you've got a giant access panel. Yeah, you can fit so much in this kayak. So, yeah, this is like the minivan of kayaks, really, or the sport utility vehicle. It's gonna take a lot of stuff into the woods, just a lot, and it's good for day trips too, like quick little short trips, or like we did, several weeks. So another thing you're gonna want is a lot of heat shrink in a lot of different sizes. This was one of the best deals I found online. This was like $5 or $6. It's got a bunch of small links, but there's a lot of it in there, and I think this was like $6 or something bucks. So on your solder joints, here's another way. If you guys don't want to get a soldering iron, I'll put a link in the description to these guys. These are really, really cool. What it is it is a waterproof heat shrink and solder in one. You just use a heat gun and you put the wires together with this. And from what I understand, it's a low temp melt solder, so high amp situations you may not want to use it, but in a normal amp like what these are rated for, and it'll tell you on the inside of the package, completely safe to use. And these are so cool, man. Some of the coolest new technology that's out there, and I'll put a link in the description. This box here, these are expensive compared to regular connectors, but gosh, just for ease and usability and knowing that your joint is waterproof, that's worth a ton. And I think these were like, God, I can't remember, $7 to $14. So really, really neat. Definitely pick yourself up some helping hands. There's all different kinds out there on the market. I bought the cheapest ones because, you know, that's what I could afford. at the time, and a lot of you are going to be that way. These are budget builds. That's why you're doing it yourself and not buying a $3,000 kayak motor. This one actually came very well recommended. Everyone was pretty happy about how heavy duty it is, and I can tell you right now, it looks pretty darn good. Some, like these, are usually really chintzy, but it feels really smooth and articulates smooth, so I'm pretty happy with that. So the other thing you're going to need is a speed controller that's matched to your battery size and your motor. So your motor, okay, the water will dictate your motor, the motor will dictate your ESC, your electronic speed control, and then your speed control will dictate your battery as well as your range, right? So this right here is capable of running 7 cells, right? So an S7, so that kind of limits us on power. This is supposed to be capable of 200 amps. Actually, when I bought this, guys, it was supposed to be 300 amps. And it showed up, and I looked at it, and I'm like, man, this thing is tiny. They have since changed the label to 200 amps because I'm sure they were replacing a ton of them. Well, the problem is, this guy's only going to run 100 amps, supposedly, on paper. I don't see that, though. I don't see these two being compatible. Like a proper ESC for a 5th scale is going to be way bigger than this. But not to worry, these were inexpensive. We're going to use this one, and then I have a 100 amp right here. We're going to use these on the other two because this is actually quite a bit of power. But if you can, always go bigger on your ESC because they can handle more power and stay cooler. Heat in this entire system, heat is your enemy. So good connections, good wire, and good components and oversized components on every single thing with the exception of the propeller is going to help you. I don't usually do kayak stuff on this channel, and a lot of you are going to be new to my channel and don't really understand like kind of what it is we do here. I enjoy kayaking, but mainly we build and restore cool stuff. This is my shop. I have mills, all kinds of different tools, welders, and the ability to do this with the knowledge to help you guys work your way through installing a system on your own boat that actually works and maybe cost $100 to $300. I mean, or, you know, the one that I'm going to build for myself that's going to be killer, probably close to $6,000 to $1,000, depending. And that all depends on your batteries as well, and if you can make them yourself, which it's not difficult. So the setup that I'm going to make for my kayak, it's going to require a motor mount and that kind of stuff. And I'm thinking that that will be almost a universal part that will mount to the motor, and then you take it and add a couple different plates and add it to your kayak however you want to mount your kayak up. Should be relatively simple. All you have to do is just end up getting to a round 2-inch hole or something to that effect. Something that would be easy for you to install on your kayak and then slide this thing in and lock it into place, and you'd be good to go. If I work with a company to build the actual mounts and they can CNC machine them, they'll more than likely be able to do that for any of you guys that need it. And for those of you guys that 3D print, I would not recommend trying to attach a motor with this much power with 3D printer. You need to go with real billet aluminum, something with some strength to it, because you're just gonna leave a $130 motor at the bottom of the lake, or it's gonna keep running and you're just gonna chop up the bottom of your boat because the wires will still be connected. Now, obviously not everyone has access to a machine shop, but there are a couple of companies out there that are getting into this kind of thing to where I can tell them that, hey, we need a bulk order of these, or can you hold this file? People are going to be calling you on it, and you can just run it on your CNC machine. And yeah, they'll be able to do that. I think eMachineShop.com is one, and I'll probably talk to them about actually making these components, because all you guys would have to do is click a link directly in my video and then order the parts. They would machine them for you and ship them out. And we're talking, these are pretty simple parts. My guess is, I don't know, you have to pay for material too. $50, somewhere in there. We'll see. All right, guys, enough jibber jabber. Thank you. Like, comment, and subscribe. These videos will start rolling out in about 30 days from now. It is January, so I would guess mid-February I'm probably going to start on this. I have a lot of parts rolling in, but yeah, we're going to be doing some motor tests, some simple videos like that, just to make sure that our ESCs work and we're good to go that way. But maybe I'll make those as videos as well. I've got a lot of parts on the way. The first build obviously is going to be my Jackson Cuda. Second build is going to be the Mirage Drive. The third is going to be the Pelican or the Pescador. I'm not really sure. And guys, if you have another kayak that you want to see, like a specific kayak, and you're kind of curious as to how it would work on your kayak, shoot me a comment, and I'll do my best to answer like what I think would work for you. So give me about a month, guys, and these videos will start rolling out.